This is just a last cut, very bit of a spring cut. A bit. Okay. What are we, point at 0.015 under. We'll let it go at that. Considering our bearing is all over the shop. .01 under there. .03 under there. .03 up on size there. .04 up on size there. So the bearings oval, tapered, out around. But any company that makes bearings is too embarrassed to put their name on them. You can guess where that came from. So that'll be a good press fit in there. Okay. Get her out before we get it stuck. Oop. Okay. Okay, our bore down there, that little one in there, we've got to bore that to 5/8 so this broaching guide will fit. So now on our part we've got these recesses to mill out. They'll be duplicated in here, and these 3 holes to do. So there's a couple of ways that we can hold this. Your best situation to hold something like this is with the outside jaws, gripping it in the chuck like that. But we can't do that because our smaller part of the jaws will close in and contact on this part before the outside jaws come in. So we could grip on this part. It's not ideal, as you really want to be gripping on the outside. What will happen, we set it in the chuck there, nip the chuck up, listen, you get that ringing? If we set it in this chuck, we're still gripping on the same surface, but the flat on the jaws provides a seat underneath that ledge there. Now have a listen. The ringing noise is gone. So that's out of these 2 setups, that's the ideal setup. We are actually going to do it in that setup. If I was to put this chuck on this rotary table, I have to remove the base plate for the chuck. So I'm going to take a chance and do it in this one and just go steady steady. That's the only difference. Your feeds and speeds will be a little bit reduced if you get problems with the ringing effect. So we'll get this one clamped down, this mounted in there, and get set up for machining. I'm going to fit a 10-inch chuck to this rotary table. I was looking at one the other day, but the price was a bit high on it, so I'm going to keep my eyes open for one. So we have our chuck just mounted down with some toe clamps. It's just lightly nipped down so we can adjust it to get it central onto the rotating table, and indicating the part in. There's a high spot there, it's its high part, so we'll come round to its low. Just give it a tap across. Okay, that's pretty good there. That's less than 0.01 millimeters, which is 3/10, coming up to 4/10, so that's fine. So we'll get it all tightened down and get a cutter set up. Close enough for the working class. So ideally you don't want to be tapping up against your indicator, but sometimes you have no option. In this case I've only got 2 arms, not 3, and I've got a bloody camera in the way, so pull that off, give these a re-engage the rotary table. Give it a knock, a nip down. And then make sure our chuck is tight. Which it is. Okay, so we'll get a tool set up, and I think we'll do the 3 holes first, and then we'll come back and scallop out the grooves that are in there. After we've tightened it, always pays just to come back and quick double check. Just to make sure nothing's moved. We're good to go there. Lovely. So we're set up over our hole. I've got a gauge pin in there at the moment. Now the hole is tapered because it's just a die cast hole. You could actually hold a pin in a drill chuck, or collet chuck, come down and centralise the hole, but I prefer this method. So because they're a tapered die cast hole, I'm getting a lot of play in the pin backwards and forwards, not as much side to side. It's pretty good side to side. So with our indicator set up, we're in between the 10 and 15 thou mark there. So we'll come round half a turn to the other side, and we're still reasonably central between the 10 and 15 thou mark. So now we'll come the other way, we'll come round to the front here, and see we're on the extremes of the 10 and on the extremes of the 15. So average that out and it puts us in the middle. Come round to the rear, and we have the same reading. So we've averaged out the hole, so we're on our centre location. So we'll get a spot drill in and mark these holes. So just because there's 3 holes in this part, don't automatically assume that they're 120 degrees apart. So this one's fine. We'll come around to the next location. That one's fine. And our last hole. Yeah, no, that's fine. Cool, safe to drill. So if we drill far enough down with the spot drill, it'll provide the chamfer for the top of the hole. So on our depth stop, just to save winding the nut all the way back up to the top, I just generally slip a piece of material in to take up the gap. So you can see there, by going in a bit deeper with the spot drill, it's put a nice chamfer on the edge of our holes. We have our cutter set up now. So we have certain degrees of rotation we're working to, so we stay equal between the holes. So these are our increments that we work through for the cutting rotation. So 136 to 224 degrees, 256 to 344, 16 degrees to 104 degrees. So that's 3 88-degree increments, and with that brings us out 16 degrees either side of the centre of the hole. We're just going to run the cutter on 600 RPM. If it feels alright, we'll step it up a bit, but we'll just take it slowly and then see how it goes. So just touching there. You can hear that ringing already. That's 2 millimeters. We'll just go around and see how we go. Okay, that's looking good. So we'll keep going with those degree increments and keep coming down till we match our depth as what is in this one. We're not going to worry about these corner details. We're just going to finish with the end mill cut. So I'll get it deeper and bring you back. We'll use our new board. I forgot I had this thing. So that's our slot finished now. Came out rather well. So it has a vague, starting to get a vague resemblance between old and new. Purely coincidental, of course. So we can take this out of this setup now. This will go back in the lathe. And the part that we're holding, we have to just machine a bit off that end, and then there's a bit of a feature to machine on the outside. It has a slight tapered feature, and of course the boss that we're hanging on to, that has a taper to it as well. So we'll duplicate that, drill the 2 holes, cut the keyway, and it's this part finished. Okay, coming up to our last machining operation in the lathe. I've just cut the taper on the nose here. I just cut that off camera. It was just a simple job of swinging the compound slide around just to match the one that they had on here. So what's left, there's this angle to machine down here. So I've just angled the compound slide around. It's just a 10-degree angle. So we'll get you set up and we'll just knock this one out, and then that's the finish of the lathe operations. So from there we'll head over and we'll broach the keyway. Yeah, it actually does nothing, this bevel we're cutting. The other one's got it, probably part of the moulding process in the other one. So we'll put it onto this one, and it will also, every bit we can take off this for a weight saving will be beneficial. Fraction more to go. Okay, we're there. Okay, so just give that a quick polish up with some emery paper and we'll go and broach this keyway. So we just consult the Mac Henry's handbook for our keyway dimension that we need. So we have a 5/8 shaft, so we look in this column here, 1/2 inch to 3/4, which gives a 3/16 square key, which is what we have. And all we're interested in is this dimension H, which is the depth H. So that's 88 to 94 thou deep. So a minimum of 88, maximum of 94 thou deep. So we add that dimension onto the shaft diameter, then we can get a measurement from the bottom of our shaft to the top of the keyway. So as we just mentioned, I think diameter of the shaft plus your keyway dimension. So we're looking for 713 minimum, 719 maximum from the bore, base of the bore to the top of the key. We're set up in the press now to broach our keyway, and there's a couple of precautions that we'll just go through first, otherwise things can get ugly. First off, these small broaches, if you're not careful, they'll snap like a carrot. So as you're pressing the broach in from the press, you've got to keep backing the press off and let the broach realign itself to prevent it snapping. The other thing is, you want to have anything underneath that's going to give that broach a soft landing if you fail to catch it, because you do not want it dropping down and hitting anything solid. That can break it as well. So we have a broaching guide, which is a neat fit in the hub, and of course that guides your broach. So we just plop him in there, like so. Bit of cutting oil on it. Make sure you put the broach in the right way around with the teeth oriented in a downward fashion. Push it in by hand as far as you can. Back it off. Back it off again. I think we're out of stroke on the press. Just come down a bit. And we'll put a spacer in to help push it through. Okay, so as you can see, it leaves the curly type chips. So that was pretty tough going getting that through, because as I said, this centre hub is quite a hard material. So I'll put a shim in behind, then we'll take the broach back in and take another cut. Okay, we take our first shim back out. There's a thick and a thin shim in this set, so we'll take the thin one out and we'll put the thick one in. Just have a bit of an eyeball and see how we're looking for depth. We'll pull the guide out. We'll have a measure. I can still see we've got a bit to go yet. We'll have a quick measure. Okay, so we're looking for 713 to 719. So we're 695. A fair way to go. Our guide back in. So we go in now with the thick of the two shims, the thicker one. Cutting oil. And away we go. Release it, let it re-centralise. And again. Okay, we'll stop and check this for another measure. We're right on the minimum. 713, we're right on the minimum. $716. So as long as we're between 713 and 719, depends where. They are a tricky thing to measure. So I'll call that good. So as you've just seen, we successfully broached our hub, the 3/16 keyway in it. Now, to tell you the truth, I was shitting myself pushing that broach through. This centre section, which is really tough material, this bloody hard, tough. So in hindsight, probably what I should have done is cut out some thinner shims for behind the broach. That would have taken the broaching cuts, would have gone through a bit lighter, and it would have been a better way to go about it. But when I've broached hundreds of keyways in my time, I've never had to do such a small keyway and such a tough bit of material. So yeah, the old clacker, it was but anyway, we'll swing you down and we'll show you how this thing assembles up now we've completed all the parts. So we have our hub with this bearing pressed in there now. So what happens is a spring sits on top of that, and the first piece in the series, this little hub, now this is the one that we had to machine the bore out oversize. So this is a sliding fit over the shaft, so it can, there we are, so it can slide freely. And the other part is this friction ring. So these all slip down like that. So this is allowed to slide backwards and forwards, and there's a fork that operates this. So this is keyed to the shaft, and this can spin. So this is on the motor going round and round. So when you put the friction ring on, there's bolts into place, and it locks the whole lot, then spins in unison as one. So when you want to release the clutch, there's a fork, pushes this, which pushes down and lets the freewheel. So in a nutshell, that's basically how it works. And of course, yeah, the motor's on this end, and this end is another bearing and a sprocket down for the drive. to drive the mower. Now, we had a couple of questions asked regarding the weight variation between a steel one and the die-cast hub. There's 371 grams difference, so the steel one's 371 grams heavier. Now, I've been told that the earlier model clutches for these mowers, the ones that precede these die-cast ones, were cast iron. So I don't think it's going to be an issue. So, well, we got through that one without any dramas. It would have been nice to machine it out of one solid piece of steel, but just wasn't an option at the time. So anyway, so our next project we're going to move on with before we, the green thing over there, before we're back into our LA Rochelaire grinding fixture, is this. This is a tailstock out of a wood lathe missing its quill. So we have to manufacture a new quill. So there'll be, up here, a number 2 Morse taper to machine in one end of it, and the other end of the quill will be a left-hand thread. I'm not sure what type of thread it is yet. I don't have any left-hand thread taps, so we'll just single point the left-hand thread, and might have to make a locking lever or something on top. I'm not sure yet. So anyway, thanks for watching, and we'll hopefully see you in the next video. Cheers.